Good morning, guys. Good morning. Hello, guys. Welcome to NEET World. So, in this session now, we are going to solve previous year NEET questions. Okay. So, before that, going into the topic now, let me introduce once again our NEET World Institute is intaking the admissions for the upcoming 2026 NEET examination, as well as we are taking admissions for the JEE mains also. Okay. And for that, the fee structure is like 333 for both 11th, 12th as well as the power step to medicine or else power step to JEE mains also. So, the course fees is 3333 per month. Okay. So, the like July 1st intake has been completed. The next intake is going to be taken on July 15th. Right. Today's date is like, yes, 14th, right. So, tomorrow the intake is going to be happen. So, you can visit the offline, that is like offline center, that is in Narayanguda. Okay. And then if you want to know the process now, you can contact to this number, or else the number will be scrolled down in the YouTube live sessions or whatever you are watching after live also. Okay. Okay, guys, let me go into the topic. So, we have solved up to the slide number 43, right? Yeah, 42 we have solved. This question we have completed, right? Yeah. So, the next question, is it visible now? Yeah, is it visible, right? Okay, thank you, it's visible. Okay, guys. So, the ratio of the radius of the gyration of a thin uniform disc about an axis passing through its center and normal to its plane of a radius of gyration of the disc about its diameter. So, they are asking the radius of gyration ratio of a disc with center and the normal to its plane, they are asking, right. So, what is the formula for moment of inertia first of all for the center and normal? For the center as well as the normal moment of inertia for disc. Yeah, it is 1 by 2 mr square as well as 1 by 4 mr square, right. So, what is the formula for radius of gyration? Radius of gyration will be denoted by k, which is equals to root over I by m, right. So, if I take the ratios for the both, no, yeah, this is center, yeah, this is for center, and this is for diameter. Okay. Now, if I take the center and normal, they are asking, no, normal to the plane. Okay. So, what it means, radius of gyration for center should be equals to, what is the moment of inertia of mr square, right. So, 1 by 2 mr square by m under root divide by, yes, radius of gyration for normal, that is diameter, will say no, d is equals to under root of 1 by 4, guys, 1 by 4 mr square by m. So, in this m will get cancelled, r square will come out like as r, like this r square and root will get cancelled, r square and root will get cancelled. So, what will be the remaining thing? Root over 1 by 2 divided by root over 1 by 4, and r by r will be there. So, r and r will get cancelled out. So, from this I can get the answer, right. So, which is equals to 1 by root 2 by 1 by 2, 1 by root 2 by 1 by 2. So, 2 by root 2 into root 2 by root 2, which is equals to this 2 and this root 2 will get cancelled. So what is the answer? Kc by K, that's diameter, will be equals to root 2. So root 2 is to 1 is the answer. Root 2 is to 1 is the answer. Yes, root 2 is the 1 is the answer, guys. Can we go for the next one? I hope you got the answer for this question. So remember, the radius of gyration formula is equals to moment of inertia by the mass. Okay, I by m, under root of I by m. So why we are doing this previous year questions? Yes, because like the formulas we have studied, but where the formula we need to use, like which question we need to use that formula, no? That's why we are doing more PYQ questions, so that you can able to understand what kind of question they are asking and what kind of formula we should use in that question, and at that place which formula we need to use. Okay, so we have used moment of inertia for, yeah, this we have used, no, center as well as the diameter in the radius of gyration. Okay, this is the concept we have used in the first question. So for the second question, yes, we'll go for the second question. Okay. A solid cylinder of mass 2 kg and radius 4 centimeter is rotating about its axis at the rate of 3 rpm. Okay. The torque required to stop after 2 pi revolution. 2 pi revolution they given, no. So what is the torque required to stop? They are asking, no. Torque required to stop. First of all, what is the formula for torque? Yeah, let me take a pen. This is the question, right? A solid cylinder, yes. So first of all, the formula for torque is equals to I alpha. Tau is equals to I alpha, right? So from this, first I need to find what is I and what is alpha. Okay, so how I can find the I? It is, yeah, it is solid cylinder, no. What is the solid cylinder moment of inertia? I is equals to 1 by 2 mr square. 1 by 2 mr square. So what is the mass of the object given? 2 kg. Radius is 4 centimeter. So I need to convert it into meter, right? So 1 by 2, mass is 2 kg and radius is, yeah, it is 4 centimeter. So 4 centimeter will be equals to 0.04 meter. So 0.04 the whole square. So 2 and 2 will get cancelled out. So which is equals to, this is 2 zeros, right? I mean 2 zeros, right? 4 by, yeah, 100 the whole square. So what is it? Is 16 by 10,000, right? So what is the final answer? So 0.0016 kg per meter square, no, kg meter square, kg meter square. Okay, this is the answer for moment of inertia. What about the alpha? We know the relation, no, like they have given one thing, it is rate of 3 rpm. 3 rpm in the sense omega is equals to 3 rpm. I need to convert into radians per second first. So what is the formula? 2 pi by 60 into 3. So 1s and 20 and this is 1. So it is pi by 10 radians per second. Omega is equals to pi by 10. And one more thing, omega square is equals to 2 alpha theta. 2 alpha theta, right? So this is the relation between alpha and omega. We know that omega they have given alpha, I need to find it. Theta is nothing but the, like they have said that 2 pi revolution, no. So theta will be like 2 pi revolution, in the sense it is 1 revolution, we will say. I mean 2 pi revolution, 1 revolution has been completed. So theta will be equals to 2 pi. So what is alpha here? Alpha will be equals to omega square by 2 theta, right? What is omega? Pi by 10 the whole square divided by 2 into 2 pi. Yes, 2 pi, that's it. Okay. So from this I will get pi square by 100, yeah, divide by 4 pi. So pi and pi will get cancelled out. Pi and pi will get cancelled out. So final answer will be pi by 400. So we got what is alpha and what is I. So can I substitute the value of I and alpha in the place of first equation? Tau is equals to I alpha. So they are asking about the deceleration. No, deceleration is the thing. So it is trying to stop. That's why it is alpha is nothing but angular deceleration, we will say, not angular acceleration, angular deceleration. So you got the formulas. No, one formula we have seen, omega square equals to 2 pi theta and I is equals to half mr square for the solid cylinder, and tau is equals to I alpha, that is torque is equals to moment of inertia into like angular acceleration, that is, but in place of stopping, no, we are taking angular deceleration. Okay. Okay, I hope you got the answer for this question, right? Calculation you can do it. The calculation part is left out for you guys. You can do the answer and you can give answer in the comment boxes, whoever watching in the online. I'll give 30 seconds time to solve it. Can we go for the next question? Yes. What is the given question here? Two rotating bodies A and B of masses m and 2m with moment of inertia Ia and Ib. So where Ib is greater than Ia, like moment of inertia of the second body is greater than the first body, have equal kinetic energy of rotation if La and Lb be their angular momentum respectively, then whether it is equal to, like La equals to 2Lb or Lb greater than La, or else La greater than Lb, or else Lb is equals to 2 times of La. This is the option given. What can I do for this question? What can I do for this question? Yes, like momentum formula is mass into velocity, but in case of rotating, no, I can use the formula I is equals to, in place of mass, sorry, L is equals to, in place of mass is I and velocity is omega, angular velocity we will use. Okay. Now what are the given things? First of all, moment of inertia of the second body, moment of inertia of the second body is greater than moment of inertia of the first body, first one, and the kinetic energy is equal. So kinetic energy of the first body should be equal to kinetic energy of the second body. Am I correct now? Okay. So what is the formula for the kinetic energy? Like half mb square is the formula for the kinetic energy, but in place of rotational bodies, no, kinetic energy formula is k is equals to half I omega square, half I omega square, where omega will be equals to 1 by, yeah, this 2 goes this side, no, 2k will be there, and divide by I. Okay, this is the omega. Now if I take this equation, I need about the relation between L and I, where I is given, okay, and omega also I have taken. Now if I substitute the values now, I will get the value of the LA as well as LB, whether it is equal or greater than or less than, I will get. Yes. So what can I do for this? LA is equals to IA, right, IA divided by into root over 2KA by IA, right. So what will be the answer? If I take this moment of inertia inside, no, it will become square. So one moment of inertia and one moment of inertia in downwards will get cancelled, root over 2KAIA, right. This is for angular momentum A. For B it is root over 2 times of KB by IB. So these are the two relations I am getting now. Now what will be the answer? So obviously answer will be LA greater than LB, right. Can I go for this next question? Yeah, you can solve one sum. So this is the relation we got. So the formula we have learned here is angular momentum is equals to I into omega. So one more thing is kinetic energy we have seen, that is of I omega square, okay. In this question kinetic energy is equal and moment of inertia of second body is greater than moment of inertia of the first body, okay. Yeah, obviously this equal, right, you can cancel it out. When you are calculating, you can cancel it out, that one. Yeah, next question will go. So what is the given question here? A body weighs 72 Newton on the surface of the earth. What is the gravitational force on it at a height equal to half the radius of the earth? Okay, half the radius of the earth they are saying no. So what is the formula I can use? F is equals to F naught into R square by R plus HD whole square. This is the formula. No, what is the given thing here? Height equal to half of the radius of the earth, which means H is equals to R by 2. And what is the weight is given? 72 Newton, which is nothing but it is F naught, right. So what will be the force now? F is equals to 72 into R square by R plus H R by 2 the whole square. Now in this what I can do? 72 I will keep as it is now, as of now. Now this is R square divided by 2R plus R by 2, which is nothing but 3R by 2 the whole square. So from this 72 into R square by 3 square and 2 square, which is nothing but 9 by 4 into R square. So R will get cancelled out, so which is equals to 72 into 4 by 9. So 9 9s are 81, then what about 9 8s are no, so it is 1 and this is 8, 8 4s are 32. So 32 is the answer, option D. Option D is the answer. Option D is the answer, guys. Yeah. So what is the formula we have learned here? F is equals to F naught into R square by R plus HD whole square, and what is the given term in the question? height equal to half of the radius of the earth. So which means h is equals to r by 2. So whatever we have taken from the question, we have substituted in the equation, that's it. So we got the answer. So is there any doubt in this question? Can we move for the next question? Okay, we'll go for the next question. Okay, so two astronauts are floating in a gravitational free space after having lost contact with their spaceship. The two will, okay, first thing, what is the given in the question? Okay, free space, right? Like free space, gravitational free space. So which means gravitational free space, which means no external force, and one more thing, having lost contact with their spaceship, the two will have. So there is no external force, but between two there will be a mutual attraction will be there. Okay, mutual attraction will be there. So what will be the answer? Moves away from each other, will become stationary, keep floating at the same distance between them. Yeah, move towards each other, like mutual attraction is there, no? Mutual attraction will be there. So first thing is, it is no external force is acting. And the second point what we need to understand is, there will be a mutual attraction force will be there. So they move towards each other. We'll go for the next question. Depends of intensity of gravitational field E of Earth is incorrectly represented by. Okay. So gravitational field, right? So inside Earth, what will be the thing? E is directly proportional to R, right? E is directly proportional to R, and outside means E is inversely proportional to R square. First thing will be linear and second thing will be inverse square. No. So what will be the given answer here? You can give, like you can say the answer. What will be the given answer? I'll write the thing also. So inside Earth, it is E is directly proportional to R. Where is the pen? It's coming. Yeah, came. Inside Earth, E is directly proportional to R, and outside Earth, E is inversely proportional to R square. So first one is linear, second one is inverse square. This is the thing. So what will be the given answer? So one will be linear, one should be linear and one should be inverse square. Gravitational field. Okay. Hello madam. Sorry sir, notification off, so I am late. So you should keep the notification on, right? Then only you can get whatever class is going on time, right? Yeah, answer is C. Correct. Answer is C. So this is the answer. So because first one is linear and second one is inverse square, right? Inverse square. You are correct. Answer is C. So we'll see one more question, okay, and then we'll wind up from there. Okay, little bit I'll zoom it. Okay, I guess it's visible now. If VE is the escape velocity and V0 is the orbital velocity of the satellite for orbit close to the Earth's surface, then these are related by. So what is the formula for the escape velocity and orbital velocity? First of all, escape velocity and orbital velocity. Yeah, it is. Where's the pen? Yes. So orbital velocity formula, VE is equals to root over 2gm by r, right? So this is escape velocity. So orbital velocity, VE is the escape velocity and V0 is the orbital velocity. V naught is equals to root over gm by r, that's it. So these are the two relation. From this relation I need to get the relation between both. Okay, so from this equation I need to get the relation between both. So what is the thing they are asking? Close to Earth's surface, then these related by. Okay, let me take VE by V naught should be equals to under root of 2gm by r divided by root over gm by r. So from this I can take root 2 outside, no, root 2 root over gm by r by root over gm by r. Yeah, VE is like VE root times how? Once again you cross check the answer. Root 2 velocity VE equals to V naught. It's correct only. Yeah. So this one and this one will get cancelled. No. So escape velocity should be equals to root times the orbital velocity. Yeah. So equal symbol is missing now. Like you have messaged that. Yeah. VE root 2 times of V naught. That's the correct answer. That is the correct answer. Yeah. So once again guys, let me tell you that in our NEET World Institute now, like the first batch has been commenced on July 1st and second batch is going to be starting from tomorrow, that is July 15th. Okay, if you want more details about that, you can contact this number or else you can come to the offline center which is located in Narayanguda, Hyderabad. Okay, we'll see guys, we'll see in the next session. The answer is C. Yeah. Okay, you can on the notification, so keep ready for the next class. Okay, we'll see in next class, we'll meet in next class guys. So which is starts from 11:50. 11:50 will be the next physics class. You can take a break and come. Okay guys, bye bye.